students, so welcome back again in this physics class. So again we are here to do the dual nature of radiation and matter. In the last classes we have learnt about photon, Einstein's equation, wave model and whatnot. We have covered almost half chapter. Now we are on the topic that is photocell. I have made you very clear what the photoelectric emission is. Now since you are clear with the concept of photoelectric emission, this photocell would be very much simpler and familiar to you. Well, if I am saying that it is a cell, then what does it mean? We will be discussing about photocell. We know that what is the function of a cell? What is the function of a cell? It is the arrangement that is converting some energy into electrical energy. And what some energy? This is an arrangement which is converting light into electric current. So if I have to start about photocell, then we should take a quick revision of all the sessions that we have done till now. We have learnt about photoelectric emission. So if I am going to start with, that would be photoelectric emission, because this is the base of the photocell. Now, if I am asking you what the photoelectric emission is, I think you guys now are able to answer me what it is the phenomena behind emission. Alright? So, you can tell me that, ma'am, whenever a frequency of radiation which would be greater than the threshold frequency is falling upon a metal surface, then instantly the electrons are going to be ejected or emitted out of it. This is nothing but the phenomena of photoelectric emission. Alright? So now since we are very much familiar with this phenomenon, we should start with the topic of the session, that is none other than but the photocell. Alright? Photocell is nothing but an arrangement that is converting light into electrical energy. Now we are very much clear with the concept that how the light is being converted into electrical energy. Why? Because if I am having a metal surface and some radiation falling over it, the radiation is composed of what? This is composed of quanta, and quanta is what? Packets of energy. So that means, and this quanta is called photon. When photons are being incident upon this metal surface, so this photon is going to be absorbed by these electrons, and when the energy that is gathered by these electrons will be overcoming the threshold frequency, will be more than the threshold frequency, then this electron will start emitting out of the surface. Alright? This was the concept that we have done till now. And now, if I am talking about photocell, then it is totally based on this phenomenon. Okay? So, let us draw the experimental setup of photocell, or a photocell, how it looks like. It is nothing but Just a minute. And then an ammeter is also connected with this arm. An ammeter. Alright, this is a source of battery, this is an ammeter. This is an evacuated glass tube. In this glass tube, two electrodes are connected. So let me draw this with some different color for you. Say this is my anode and this is a cathode. This cathode is made in some semi-cylindrical shape and this anode is made in the form of a wire. Why it is made in the form of wire? Because we want the light to fall upon this surface like this. The photons, and we do not want to be obstructed by this anode. So that means to prevent the obstruction of radiation over the cathode, we have made this in the form of wire so that all the maximum amount of energy is getting to be gathered at this point. Alright, so we have made this in the form of a wire. Now this is an anode, this is a cathode. What happens is when we are allowed to give some radiation or light over this cathode, what will happen? Again the same concept, electrons are going to be ejected. You are going to see here also what happening is electrons are going to be ejected. Similarly, first of all that I forgot to tell you, this cathode is nothing but made up of a photosensitive material. Then only the electrons are going to be ejected. And what is the photosensitive material? It might be used with a thin layer of cesium, alright, or we can do one thing, we can apply a photosensitive plate in the inner side of this tube. There are two methods to apply a photosensitive plate. So in this case, we are applying a photosensitive at this cathode, okay. So now if the photon will fall upon this very surface, what will happen? Electrons are going to be ejected, okay. So since electrons are going to be ejected, where are they going? Where will they go? This is an anode, and if we are placing it a positive potential, then what will happen? The electrons are going to be attracted towards this anode. Why? Because electrons are having negative sign, negative charge, and this anode is at positive potential. Say I am giving 10 volt of potential at this anode. So what will happen? My potential difference, due to this potential difference, electron will start going or attracting towards this anode, okay. Alright, so as I always say that, don't go over the length of the question. More lengthy the question is, more easy will it become. Now here I can see that from A to D there are options. The question is from here to here, from statement 1 to statement 2. So let us just see what is the question saying. Statement 1 says that when ultraviolet light is incident on a photocell, its stopping potential is V0 and the maximum kinetic energy of the photoelectrons is K max. Now they are saying that when the ultraviolet light is replaced by the X-rays, the main important line in this question is this, when the ultraviolet light is replaced by the X-rays. So they are asking what will be the both V naught and K max increase. According to them, this is the statement which is saying that on replacing the ultraviolet light by an X-ray, this V naught, that means stopping potential, and the K max, that means the kinetic energy of the photons, will increase. Now let us just see whether this statement is true or false. According to them, the second statement is photoelectrons are emitted with the speeds ranging from 0 to a maximum value because of the range of frequencies present in the incident light. According to them, they have given us a statement and we have to show them whether this is true or false, because 4 options has been given. In that 4 options you can see statement 1 is true, statement 2 is true, statement 2 is the correct explanation of statement 1. These are 4 options and we have to take a one particular answer, right? Now I can say that I have to proceed this question with something that is E equals to h nu. In the case when I am changing the light ultraviolet to X-ray, I can say that the frequency of X-ray is higher than ultraviolet rays. So I can say that frequency of X-ray is higher than UV rays. Now if frequency is higher, that is quite obvious that energy would be higher because E equals to h nu. So we will say that energy of X-ray will be higher. In the question, let us just see what was the first statement. According to them, when the UV is replaced by X-ray, both V naught and K max increase. K max is what? The kinetic energy, the maximum kinetic energy. And we can see here, because the frequency is increasing, we can say that the kinetic energy is increasing. So finally, we can just write this energy as Ke max. That means it is been increasing. Now let us just see how can we show them that yes, whether the stopping potential is also getting affected or not. So let me just tell you, there is a relation between energy and stopping potential. First of all, what do we mean by stopping potential? It is that negative potential, that minimum potential at which the photocurrent stops. That means no photocurrent will flow, no photoelectric emission will take place at that stopping potential. So we can say that this is kinetic energy max. This is again photoelectric equation given by the Einstein. Ke max equals to h nu minus h nu naught. This is the work function. And we can write this kinetic energy as E into V naught. So if I talk about the stopping potential, I can write it as h nu by E minus h nu naught by E. Now you will see that because the kinetic energy is increasing, we have seen a relation that if the kinetic energy of the incident photon is high, so the number of photons, the frequency, you can say if the kinetic energy of the photon is higher, so that means photons will be getting emitted at a higher rate. And then you can say that because the photon is getting emitted with a higher rate, you need to apply more energy to stop them. So that means your stopping potential would be also high. So we can directly conclude from there, since kinetic energy is maximum, so stopping potential will be maximum. we have concluded these two things, and so we can say this statement is correct. Why? Because on changing the light from UV to X-ray, we have seen that both the stopping potential and the kinetic energy max has been increased. So this statement is correct. Now let us just see and ignore those options which are irrelevant for us. In the option 1, we can see statement 1 is true, statement 2 is true, statement 2 is the correct explanation of statement 1. So right now we are not aware for statement 2, so we will not touch this A option. While in the second case, I can see statement 1 is true, statement 2 is true. I know that statement 1 is true, but I don't know about the statement 2. So again, I will not touch this option. But in the C option, I can see statement 1 is false. So that means this option must be incorrect. I can totally ignore this option because I know that this statement is correct, right? Now, in this statement, in this option, statement 1 is true and statement 2 is false. I have ignored one option from my question. Now, I will just let's see what is the statement 2. According to statement 2, the photoelectrons are emitted with the speed ranging from 0 to a maximum value. Yes, this is true that the photoelectrons emitted, they ranges from 0 to a maximum value. But the reason that has given because of the range of frequencies present in the incident light. This is not the correct reason, because we know that the photoelectrons emitting and ranging from 0 to a maximum value, this is happening because of the collision. Because at the time of collision, they lose their energy, and due to which this ranging from 0 to a maximum value. So we can say that statement 1 is true, but statement 2 is false. Because this is not the correct reason of this statement. This is not supporting this statement. So we can write statement 1 is true and statement 2 is false. So this is the correct answer, right? Now let us just move to the second question and see what is the second question saying. All right. So we are having something like a numerical with us. As I have told you that the level of question would be a little bit higher than NEET, but you are going to solve it very easily. And also I should tell you, this is a very scoring chapter, because in this only 1 or 2 things you have to remember. You have to focus on the graphs that has been drawn in the chapter, and you have to focus on the equations, photoelectric equation, formula for the work function, and formula for the stopping potential, the relation between wavelength and stopping potential. This all you should know. The relation between wavelength and kinetic energy, between momentum and wavelength. So this is such things, the basic things that you should know about this chapter. Then your way would be very much clear. You would be going very much smooth if you are knowing these basic things. So let us just see what is the second question. The surface of a metal is illuminated with the light of 400 nanometer. So let me just write, the wavelength has been given as 400 nanometer. And what else? The kinetic energy of the ejected photoelectrons was found to be 1.68 electron volt. So let me just write here, kinetic energy of the ejected photoelectron was 1.68 electron volt. Now, what is the work function of the metal? We have to find this work function. Now, you know that work function is what? The minimum energy that is required to eject the electron from the metal, right? Now, we know the formula. The formula says kinetic energy of the emitted photoelectrons is h nu, that is the energy of the photons, minus the h nu naught. That means this is the work function. You can write it as phi naught, and we have to find this phi naught. Now, in the question I have been given the lambda and I have been given 1.68 the kinetic energy. So, let me just start with this. Just you can write the phi naught here because you have to find this. Also, you can focus over one thing. Here in this question, we have been given the value of hc. So, we are generally going to put this value. You can remember this value because multiplying this h with c is a constant term. H is constant, c is constant. So, you can just remember this term 1240 electron volt into nanometer. Now, in this question, we are having 1.68 equals to h nu. I can write this nu in the form of c by lambda minus work function. Now, if I have to find the work function, now you can see how simple this question is. You just have to know about this equation and nothing else. How important this equation is. And you can score a very good marks if you are clear with this. So, now let me just bring this phi naught to here because we have to find its value. It would be hc by lambda minus 1.68. Now, what you can see here, hc, the value of hc has been given, that is 1240 electron volt into nanometer. So, let me just write this value 1240 electron volt into nanometer divided by the wavelength. Wavelength is 400 nanometer. Now, you have to subtract this by minus 1.68. This nanometer cancelled. Now, I am having 1240 by 400 minus 1.68. Now, you can solve it very easily, and whatever will be your answer coming, whatever will be the thing, whatever will be the number that will be coming out here, that will be your work function. I have just told you how to approach, how to proceed in this question, but the answer will be given by you. And whatever will be your number that will be coming here, let me just write again, that would be 124 by 40 minus 1.68. Just solve for this and find the value out. Use your calculations, use your calculators and bring out the value of this equation, right? So, whatever will be your value, you just have to tick over here whichever is the correct option. Alright. So, according to the question 4, question number 1, the direction has been given. Let me just introduce the exam of JEE Advanced before you. You will be encountered with 4 or 5 sections in your exam, in your JEE pattern, advanced pattern. In that pattern, you are going to see the match the following, the true false, fill-ups, comprehension type question, reason and assertion type questions, this one multiple type of questions where only one option would be correct. The second one would be more than one option is correct. So, basically there are sections which you are going to see in this pattern, right. Now, the first question is, direction has been given that question number 1 to 4, each question has 4 choices and we have to select any one, right. So, now let us just look at the question. In a historical experiment to determine the Planck's constant, a metal surface was irradiated with the light of different wavelengths. The emitted photoelectron energies were measured by applying a stopping potential. The relevant data has been given to us. Let us just see what is to be found. Given that C is this, E is this, Planck constant is this, we have to find, so Planck's constant we have to find from such an experiment. In the history, the scientists were doing an experiment where they were irradiating the metal surface with different wavelengths of light, and the readings are here. At this wavelength, the stopping potential was this. At this particular wavelength, the corresponding stopping potential was this. At this wavelength, this is this. Now let us just find the value of H, and as I have told you, the important thing in this chapter is the Einstein's photoelectric equation, because this has become our favorite part of the question and favorite part of the examiner to bring out the question. So you have to remember what is the photoelectric equation. Now let me just write this equation once again before you. This is kinetic energy of the emitted photons is equals to h nu plus the work function, or you can say here the kinetic energy is the energy with which the electrons are emitting, and this h nu is the energy of the photons which are irradiating over the metal surface. Now in this table you can see, let me just consider this as lambda 1, this as lambda 2 and this as lambda 3. So the corresponding potential voltages will be V1, V02, this is V01, this is V02 and this would be V03, right. Now what I can do from here is, you know that the kinetic energy can be written in the form of E and V. So I will be writing it as EV equals to h nu plus, not plus, this is minus here, right. So this is your Einstein's photoelectric equation. Now from this equation you are having number of lambda and number of stopping potentials. Can we write this nu into the form of wavelength? Of course. So EV equals to hc by lambda minus phi naught, because we know that nu equals to c by lambda. Since nu equals to c by lambda, so we have put this value into this nu. We are having this equation now in the form of lambda. Now from this equation you can write here as EV1 equals to hc by lambda 1 minus phi naught. Phi naught is the work function, and for a particular metal the work function would remain same. Whatever will be the wavelength that will be radiating over the metal surface, it is not bothered about this. The work function will remain same for a particular metal. So for this we can write here as EV2 equals to hc by lambda 2 minus phi naught. Now let me consider this equation as equation number 1 and this as equation number 2. What I can do here is, I can see that V1 and V2, lambda 1 and lambda 2 I am having with me. This is lambda 1, this is V1, this is lambda 2, this is V2, the stopping potential. Now here this is also the stopping potential. You can write here as EV0. Now what we can do over here is, we can subtract these two equations. So let me just write over here as V01 minus V02. This will be equals to what? This will be equals to Hc 1 by lambda 1 minus 1 by lambda 2. This has common and this has become as minus 2 phi naught. Right. Now you can see here, since phi naught and phi naught are equal, what I am having, if I am going to subtract this, this will not be the addition, this will be just cancelled out, because phi and phi will going to be cancelled, right. So now I am having this equation. From here you have to find the value of H. So how can you find the value of H? H would be E into V01 minus V02 divided by 1 by lambda 1 minus 1 by lambda 2. Now just see in the question what are the values that has been given. We have to find the value of H. In the question I am having the value of E. You can just look at here, this is the value of E and this is the value of C. lambda 1 is 0.3, lambda 2 is 0.4, corresponding V0, V1 are 2 and 1. So I am going to put these values in this equation that we have got. So H will be equals to E is 1.6 into 10 raised to the power minus 19. So where is the C that has been gone? This will be C here. H will be E by C V01 minus V02 divided by the wavelength. So now we are having something like this, V01 minus V02. V01, you can see from their equation, this is 2 minus 1. Now 1 by lambda 1 minus 1 by lambda 2. You are having in your equation as 1 by lambda 1 is 0.3 and lambda 2 is 0.4. So you can see here 1 by lambda 1 will be 1 by 0.3, 1 by lambda 2 will be 1 by 0.4. So we will be doing it. Alright, now what you will see here, if you are going to solve it, you will be having your value into the range of 6.4 into 10 raised to the power minus 34. So we have found our answer in this range. Now let us see, is there any option in the question or not? So let's just move to the question, and yes, we can see here this is 6.4 into 10 raised to the power minus 34. So that means the correct approach has bring us to the correct answer. If you are starting your question with the right equation, you are definitely going to reach at the correct target. So yeah, we have completed this question, and now let us just see what is the question number 2. Okay. Okay. So the question number 2 says, that a light of wavelength lambda ph, it falls on a cathode plate inside a vacuum tube as shown in a figure. This is a vacuum tube and this is a cathode plate, and lambda ph, say this is lambda ph, photon is falling over this cathode plate. Now further next, the work function of the cathode surface is phi, and the anode is a wire mesh of a conducting material. This is anode and this is a wire mesh kept at a distance d from the cathode. Suppose this is a distance d. Right? Now a potential difference V is maintained between the electrodes. You can see potential difference has been maintained. If the minimum de Broglie wavelength of the electrons passing through the anode is lambda E, if this is the de Broglie wavelength of the electrons, that means this is lambda E according to the question. Now what we have to find in the question? Which of the following statement is true, or which of the following statements are true? We have to tell them. Right? Now because we are solving those questions in which only one option can be correct. So only one option would be correct in amongst these 4. So let us just start with this. For the large potential difference, lambda E is approximately halved if V is made 4 times. So let me just start with the question. Because here potential difference is also applied across this tube, so our energy because of this potential difference will be added to it. Let me just write with the photoelectric equation, and that equation is E equals to h nu, or you can write it as C by lambda minus the work function. Right? This is the equation. Now because potential difference is also applied, we have to add an extra energy, and that would be E into V. Right? Now you can write this energy into one form, that is P square by 2m. You know that there is a relation between momentum and energy and also with the mass. So we can write it as P square by 2m equals to hc by lambda photon, because this is the energy of photon, minus phi plus E into V. Now you are having this equation with you, and what you have to do is you have to find out whether for large potential difference lambda E is approximately halved if V is made 4 times or not. We are having P square by 2m. You know that there is a relation of de Broglie wavelength h by P. This is a de Broglie wavelength. So we can write this P as h by lambda in place of this P. So here P will be h square by lambda E square into 2m. This is the wavelength of electron, right? Because we are just talking about the energy of the electrons that are being emitted. So here the wavelength of electron would be written, right? So now we are having hc by lambda ph minus phi plus EV. Now you are having this equation with you. What you can see from here is that you are having a relation between this lambda E and lambda pH, right? We are having this relation now. This is, you can say, because you know that advanced level of JEE is a little bit higher than the JEE mains.